Imagine driving a car under the sea. Your head is being pressed down by millions of tons of seawater, which is built with almost microscopic precision. It sounds like a scene from a science fiction, but in reality, it is just a remarkable achievement of modern engineering. But the question is, how humans build such huge structures where there is enormous water pressure on one side and unstable soil, and the entire environment completely isolated from the surface. In this documentary, Unmatched Bangla will take you below the waves, where we explore how human civilization makes the impossible possible and reveals the amazing engineering hidden deep in the sea. To uncover this mystery of the sea, you have to watch this entire video by Unmatched Bangla. So, without wasting any more time, let's start the video. Imagine going from one island to another, or crossing a vast bay in just a few minutes without ferries or high bridges, is all possible thanks to underwater tunnels. Not only do they keep the movement of goods and people around the world moving and ensure fast, safe, and efficient trade. For many countries, especially port cities, underwater tunnels are serving as the main arteries of economic and industrial development and are creating new opportunities for global trade and regional development. Building an underwater tunnel requires extensive preparation and almost perfect design accuracy. Each step is calculated very carefully to ensure the viability and safety of the entire project. The first step begins with a detailed survey of the seabed. Engineers analyze the terrain under the sea, collect soil samples, and test rock layers, so that the geological structure of the bottom, the bearing capacity, and the construction can be affected. Such hidden risks can be identified. In addition to technical work, environmental issues are prioritized at every stage of planning and design. The project team has to assess what impact the construction of the tunnel will have on the marine ecosystem, so that marine life is protected and natural habitats are damaged as little as possible. For this to be done, noise reduction measures are taken during construction, and sometimes artificial coral reefs are installed so that new views are not created for marine life. Once the survey is completed, the construction phase begins. One of the most widely used methods of constructing underwater tunnels is the immersed tube method. In this method, large reinforced concrete segments are first built on land. Each individual segment is approximately 217 meters long and weighs more than 73,000 tons. These segments are constructed with great precision so that they are perfectly connected and watertight after being placed underwater. Each segment has multiple sections for different uses. 2 main chambers are reserved for highway traffic, 1 for rail traffic, and another for service corridors for future maintenance and inspection. Once the segments are completed, they are transported to the sea and carefully lowered into a pre-excavated location on the seabed using floating parts and specialized cranes. Each segment is then connected in stages to create a continuous tunnel of the required length. The most critical step in this process is the junction of the segments. If the sealing is not done with great precision, seawater can enter and pose a serious risk. To prevent this, rubber or gaskets are placed between each segment to ensure a completely watertight connection. At the same time, a layer of sand and gravel is placed on and around the tunnel to prevent the buoyancy force caused by water pressure. After all the connections are securely locked and stabilized, the temporary end branch heads are removed. As a result, the individual tubes are combined to form a continuous and completely underwater tunnel. However, this technique is only suitable for areas with stable seabeds and dead currents. Where there are strong currents or complex underwater terrain, the immersed tube method is not effective, because in such an environment, the tunnel is anchored firmly and it becomes extremely difficult to maintain a watertight condition. In addition to the underground pipe-laying method, the shield excavation method of tunnel construction is also used. The shield tunneling method, also known as tunnel boring machine, TBM, is the latest form of modern tunnel construction technology. But the story doesn't end here. As the tunnel boring machine slowly moves forward beneath the seabed, cutting through layers of rock and soil, it creates a perfectly shaped tunnel while simultaneously installing strong concrete linings behind it. It's like a giant mechanical worm carving its way through the earth with unbelievable precision. Inside the tunnel, advanced ventilation systems continuously supply fresh air, while powerful drainage systems remove any water seepage. Thousands of sensors are installed throughout the structure to monitor pressure, movement, temperature, and even the tiniest cracks, ensuring the tunnel remains safe for decades. But building the tunnel is only half the battle. Maintaining it under such extreme conditions is an ongoing challenge. Engineers conduct regular inspections, use robotic systems to detect faults, and apply cutting-edge technology to prevent any possible failure. Because even the smallest mistake under the ocean could lead to catastrophic consequences. Yet, despite all these challenges, humanity continues to push the limits. From the famous Channel Tunnel connecting the United Kingdom and France, to massive underwater networks in Asia and Europe, these engineering marvels are redefining how the world stays connected. What once seemed impossible is now part of our everyday life. Underwater tunnels are not just structures of steel and concrete. They are symbols of human ambition, intelligence, and determination. They prove that no matter how deep the ocean or how strong the pressure, human innovation can always find a way. So the next time you travel through a tunnel beneath the sea, remember, above you lies an entire ocean, and around you stands one of the greatest achievements of modern engineering. If you enjoyed this journey beneath the waves, don't forget to like, share, and subscribe for more mind-blowing documentaries. So friends, I am ending today's video here.